And we are live. Yes. Yes. Oh, sorry. Message. Okay. Sorry. I had to. So we were doing the thing with the mouse, and yesterday and this morning I actually intensely thought about it, and I like it, but like these values are useless. Like, we don't want the values themselves, we just want so get will get virtual will and get row will. So the virtual will is something like this. The row will is something like this. So basically it's the will multiplier. Okay, we don't really need the row will value. And will row. Okay. This thing right here doesn't really matter. So these two, get the position, get the button, set the set wheel. Okay, this is the raw wheel. When we set sorry, let's just put it here, like, why not? I think it makes more sense. I think it makes more sense. Will raw, will virtual start, will virtual, okay. And here we put the to do for the momentum thingy. Set the position. Well, let's say this is good because it's simple. It's a one-liner, we can put it here. Set the button 0 raw wheel. 0 raw wheel, okay. The update with the damping factor, okay. When I compute the update, okay, the idea is that I take the current virtual thingy, I start from the wheel, and from it I subtract the starting the wheel start multiplied by the damping factor multiplied by the delta time in seconds. So multiplied by the delta time in seconds. This is a delta. Okay. It's the amount of time that passed from the previous frame to the current frame. Okay. The time to process the last tick. From this I multiply with the damping factor. If this is because the damping factor is like a percentage per second. So the idea is this subtracted. The problem is that this is not like I needed to pull out the pen and paper and do some math. I need to pull out the paper, pen and paper, and So let's do something like this. Okay, so that is that we have the, let's call it virtual. Okay, so this is the virtual wheel. Okay, this is a value of virtual wheel at frame I, let's say. This is vs is the virtual wheel starter, or I could say simply s start. And what happens is that, suppose that at frame 0 a will event, input event, occurs. I always forget. Occurs. Okay. I was already doing a mistake. Okay. So we know that V0 will be a given will be the will start, basically, because we set the will. Okay, so the will start is the same as the will. I can do this, which is better. So that is that the virtual v1, so v1 is right after an update, so is v0 minus the starter times the damping factor, so the and let's call delta I is basically T I minus 1, it's Ti minus Ti minus 1, so it's the delta time for frame I. Okay, so let's say Ti is time in seconds from the start of the app's start. Okay, and now this is the delta time for frame I. Okay, so the time it took to process how is it? Delta 0 would be delta 0 by definition we define it as 0. Okay, then the delta I is basically ti minus 1. Yes. Okay, and delta 0, okay, so this is times delta what? It's delta 0 at this point. So the general formula is that V0 is S, and Vi with I greater than 0 is basically Vi minus 1 minus what? The start times the damping factor times the delta for I minus 1. So let's do some let's unroll this recurrent relation. Was recurrent equations? Recurrent relation, yes. Yes. So the idea is that we do something like that. First, we start from, so V0, we say it's S. V1 is V0 minus S times the damping factor times delta 0, which is V0 minus S times D times 0, which is V0. What? There is something wrong. No, it's true, because the first will be 0. Okay. The second, so suppose that at frame 0 a will input event occurs, so it will be set at frame 0 a will input event occurs. As soon as we start, suppose that we start, this is 0, a will input event occurs. Okay, so here we do this will be 0, and thus this would be basically all 0, so it's just like that. Okay, then we have something like let's keep it like that. Let's keep it like that, because I'm not convinced about this. I'm not really convinced about this. Like, seriously? That is that V2 is V1 minus SD delta 1, which is V0 minus S times D times delta 0 minus S times D times delta 1. Okay, obviously V3 it's what? V2 minus S times D delta 2, which is V2 minus, V2 is this thing right here, so it's V0 minus S times D times delta 0 minus S times D times delta 1 minus, okay, minus S times D times delta 2. Okay, you can easily see that well, this is like that. You can group these like that, like this. V0 minus S times D times delta 0, okay, plus delta 1. Everything makes sense, right? Minus SD delta 0 minus SD delta 1. This is the same thing. It's V0 minus S times D times delta 0 plus delta 1 plus delta 2. Delta 0 plus delta 1 plus delta 2. Okay. Now it's easy to see that Vk is what? You know, it's this thing right here, okay, which means that is something like V0 minus S times D times what? Delta 0 plus delta 1 plus blah 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 plus delta k minus 1. Oops. But now it's easy to understand. You're doing the sum of deltas. How did we define the deltas? Well, so we have the like that. So you have something like V0 minus S times D times delta 0 is 0 plus delta 1 is T1 minus T0 plus delta 2 would be so this is delta 0, this is delta 1, the delta 2 is the delta time for the current frame is the delta time. The delta time for a current frame is computed by the timestamp basically at the beginning of the current frame. Okay, elapsed the time from start. Okay, I don't know if it's very sound, but let's roll with it. t1 minus t0, so this is t2 minus t1 delta 2. Something magical happens. Something magical happens. This t1 cancels out with this t1. Okay. If we go with delta 3 it's t3 minus t2, and this t2 cancels with this t2. Okay, until you get to the tk minus 1 minus tk minus 2. Bad choice of indices, by the way. K minus 1. Here we know that this thing cancels out. Everything this will be cancelled out by the next one. So what we have at the end of the day is something like v0 minus s times d times what? 0 doesn't really matter. We have t k minus 1 minus t0. But what's this? This is just the t0 will be the elapsed time at the beginning of the frame from the apps start. So we know that t0 is basically 0. So this is by definition t0 is 0. So we know that this thing right here is v0 minus s times d times t k minus 1. So what did we actually prove here? We proved this thing right here, that vk is v0 minus s times t, so the starting value times the, and we know that v0 is s, so we can also say, oh well, v0 is s, so we know that this is s minus s times d times t k minus 1. So what we proved that at the end of the day, t k, what? It's not tk, come on. Vk is just s minus s times the damping factor times tk minus 1. Okay. Okay, so it's basically the same as doing that, which is cool. So I will write this because it's way simpler. Obviously we don't have that, but we know that we can simply use the deltas. Using the deltas, so an interesting property is that we can use the deltas instead of the absolute time. So the two interesting facts: we can use the delta instead of the absolute time t I minus 1. So first important fact. Other important fact, we can just use s. Okay, so everything looks sorta worked out. and thus why is this important? Why did we get like into this rabbit hole? The thing is that I just wanted to plot this function. Okay, I just wanted to plot this function. Like I solved the recurrent equation, or recurrence relation, sorry. Because in Italian, yeah, relazione di ricorrenza, recurrence relation. Very easy. I just wanted to plot how vk changes depending on S and D over time, which we call X. Okay, so from here it wasn't really very clear how to plot. I wasn't really very clear from this how to plot the values of our virtual wheel actually changed. Now I can. Okay, so that's why. Oops. Okay, we don't have. So the idea is that now I can just do Desmos graphing calculator and say, okay, our wheel, it's just the start minus the start times the damping factor times the our current time value, basically. The start can either be negative or positive. Let's say minus 10 and 10 for the damping should go from 0.1 to 1 at increments of 0.1. Seems fair enough. We can see that depending on the damping factor, so suppose that we have a start of, I don't know, 10. Okay, let's see how with 0 damping factor over time we stay at 10. With 0.1 damping factors, after 1 second we get to 10 linearly, like we get to 0 linearly. With dot 2 we get to 0 faster, but always linearly, and the thing goes on basically, okay, faster and faster until the damping factor is 1, which means that after 1 second we linearly go down. I don't really like this linearity of the thing, okay, or better, I don't really, oops, so get virtual wheel. Get wheel is not a member. Get virtual wheel. So the idea is that, okay, cool. You see, like how, like, another thing that's the problem is the momentum of the thing. So this commit, in this commit we did basically nothing apart from in the input, it's a good idea to say, okay, here the virtual wheel, you can just use the virtual wheel start, okay, the damping factor, and okay, So basically, okay, so basically this looks good. This is just the because you can easily see like this thing goes down indefinitely. We don't want that. We want to be able to keep it up. Like we want to stop the madness as soon as it reaches 0. Obviously, we don't know, like this is contiguous, but our is discrete, so we could just go beyond 0, just skip 0. So we don't check for the 0 itself, but we check for the, like when we change the sign, when our start value has a different sign from our virtual, from the current, okay? Damping factor, the update gets called the shift F12. Wow, don't really like it like that. I like it more like this. It gets called now. This is not mine. This is not. Okay, here. So the idea is that we can create a input and call it. Should we put it in input? Not really, because it's the input tracker, the thing that actually cares about that. So we could say struct mouse config and the wheel damp and the mouse damp mode, linear, quadratic, this is non-linear quadratic, mouse damp mode, damp mode, and we pass, this struct right here. Mouse config, the input tracker obviously says, dude, I don't have mouse, so I can just move away the tablet. That we did the math, so we can just go on encoding, doing real work instead of mathing. Mouse config, did a bit of math. I already forgot how to type. This we put it in here. Percentage per seconds of value used, percentage per seconds of percentage per seconds. Percentage per seconds of the starting value to use for damping. Value to use to damp the current percentage per second of the starting wheel value to use for damping the current wheel value. Mode. The mode is the mode. Like mouse config. Oops, this is mouse config. Update, we pass the mouse config. M. So, whoops, we need to move this to the input. Then keyboard, the mouse, and update mouse config const reference mouse config can simply do this. Like in the input tracker, I would like to copy it and be done with it, but in all other scenarios I don't really care, I just pass by reference. And then obviously the delta time in seconds. So the config dot with damp, and the idea is that we do the switch config dot damp mode, and then we pray, and our prayers have not been heard. Case mouse damp mode linear. Come on Visual Studio, you can do it. It's not that hard. Default, dude, this should never happen. Unreachable. Fuck off. So if we do the linear damping, this is what we want. This is what we want. If we want the S minus S times, that is that the damping factor is the percentage per seconds. Okay, it's the percentage per seconds. If I square it, so I need to square something. Either, since we need a parabola, we need to square the x. Okay. Now, this is what happens, and people should say, "Oh, cool, it's the same." Not quite. You see that it's not quite the same. This reaches 0 in 2 seconds. This reaches 0 in 4 seconds. What's the problem? Well, the problem is simply that this is a delta time. It's seconds. If we square it, it's seconds squared. This is percentage per seconds. Okay, these are just units. So the idea is that this is basically unit per second. Okay, this is seconds squared. Well, something is wrong. The math is not mathing. Like, we want a unit and we get seconds. We are not doing something right. Since this is a unit and this is basically a unit, the only thing that I can use to cancel seconds is just squaring also this dude right here, and this keeps things simple. So at the start it's slower, okay, and then it becomes faster. So at the start you can see equals I don't know, C. No. This. So let's put it right here. This. After, let's say 5. This thing is after 5 seconds the value of our virtual wheel will be 1.6. In this case it will be 2.35. so you know, okay, that it's smoother, basically. It's smoother, okay. The variations is different, and I think that the quadratic is a little bit better. You can also do the cubic if you really care about it. This is even more interesting. Okay, with this cubic like start very slow, the decrease is very slow, so it's something that I wanted to experiment with. So, and we can, like, once we know the rules, so we can play however we want. The update, the quadratic, well, the quadratic is basically the same, but we need to square. So float wheel damp squared, and it is to just do this, and then the dt sec squared, and I hope everything makes sense, right? Input tracker, oops. Input tracker dot will damp dot damp mode mouse damp mode, let's say linear for now. Let's say linear. Something ain't right. What was the... Oh, because it was 6, not .6. Okay. I don't know, maybe 5 is better. It's a little bit... Let's look at the quadratic. The math ain't mathing. The math ain't mathing. Why the math ain't mathing? The math ain't mathing because percentage of seconds of the starting wheel value to use for damping, because I always supposed that the wheel damp is between so 0.9 something is not Well, but why? Why cannot I say that the damping... Why not 10? Everything should work. Everything should work. Yes. Like I want 500%. What's the problem? In a second makes sense. Yeah. I'm stupid. Like why? Do I need... This is the linear and works. The quadratic doesn't work. Oh my god. Because it's incredibly slow. That's why it doesn't work. That's why it doesn't work. Because it is incredibly slow. We'll dump squared. So in our case, oh, because the delta time would be very small. The delta time is incredibly small. That's why. Multiplying something like we get something way smaller. Yeah. But things should even out. Apparently they don't even out. Apparently they don't even out. What happens if I use the normal delta time? Just to know. I obviously made some errors. I'm not. I'm missing something. Let's start. Am I doing things right though? Probably I'm not doing things right. Probably I'm not doing things right because I have to solve a new recurrence relation, and I have to solve something which has this squared, which is not a problem, but this squared plus this squared, which would translate to d squared plus d squared, okay, which is d squared plus d squared plus d squared, but the problem is that this is 0, this squared is t1 minus t0 squared, which is t1 squared plus t0, so t0, let's say t1 squared plus t0 squared plus minus 2t0 t1. Should be okay. So the math, I have to check out if this thing still works though. Have to check out if this thing actually works as of right now. Well, let's check it. No big issue, no biggie. No biggie. Yeah. So delta 0 squared plus delta 1 squared plus delta k minus 1 squared, 0 squared plus, which is 0, come on, plus t1 minus t2 squared plus t2 minus t1 squared plus t3 minus t2 squared, oops, plus blah blah blah, plus tk minus 1 minus tk minus 2, bad indices, squared. So this is 0, don't really care about it. t1 squared plus t2 squared. No, this is completely wrong. t1 t0. It's t0 squared, t1 squared plus t0 squared minus 2 t0 t1 plus t2 squared plus t1 squared minus 2 t1 t2 plus t3 squared plus t2 squared minus 2 t2 t3 plus tk minus 1 squared plus tk minus 2 squared minus 2 tk minus 1 tk minus 2. What is happening? Well, it's happening that shit does not cancel. Shit does not cancel. That's why. Oh, okay. So we can forget about the quadratic. We can forget about the quadratic. Basically, it's a huge fuck off to all of us, because t1 it would be yeah. Does it not? Doesn't cancel out. So this is garbage, basically. The quadratic is garbage. So the math was mathing for the old one, but the math is not mathing for the new one. How can I fix this? Because this works. Yes, because this works, because this is what we want, but we don't have this. We don't have this. That's the problem. That's the problem. That's the problem that we have. Because if we simply had not the delta time, but the time, we could do it. We could do it. But the problem is that not the time from the start. Because this x is not the time from the start, mind you. It's the time the last time at the beginning of frame from the upstart. It's from the up, because we are supposing that at frame 0 a will input event occurs. Because this by def 0 is 0 under our assumptions. Okay, so we should record the time in which the will event actually occurred, and from there do the thing. So when setting in the main, in our application, we should keep a struct in our application that registers the current frame starting the time since the start of our application. Okay. And pass it here. And the time. And the current, like the time of the start, the time when the current frame started. Yeah. Well, I'm out of time, so we'll do it tomorrow, okay? Because I think it's worthwhile to like understand what's happening. Like, it's worthwhile to try and do things in a sane way, okay? So have a good day or night or evening or whatever, and see you next time.